Yeah, we've reached a point here where we've got enough tests, I guess we might say, that we can do what is called the comparison test. Compare one series to another series, and based on how those are related, we can tell whether maybe one of them converges, if one of them converges and the other one does, or if one of them diverges and the other one does. Is the idea behind the comparison test, comparing one series to another series, maybe a series we know something about, to a series that's a little more complicated, let's call it. It's a comparison series, so it's good sense that that's what it's called, because we're comparing two series. Here's a statement of that. All right, so suppose the series of A sub n and a series of the B sub n's, two different series, and both of those are made up of positive terms. And sometimes you can make a little bit of adjustment. Maybe one term is a negative term, or a couple of terms, a finite number of terms are negative, and just make the adjustment, and this comparison can be used there. But technically it needs to be, both series have to be made up of positive terms. And just a little bit of how it works. So usually what the B sub n series is, it's a series that we make somehow out of A sub n's, or by cutting it down, the A sub n series, cutting it down a little bit, and trimming a few terms off of it, let's say. And so the B sub n is definitely going to be related to the A sub n. The B sub n is going to be an easier series. It's a series that you know more about, because it's, like I said, a simpler series based off of the A sub n series. So that, it's not just two random series. Pick one out of the blue. You got a series, and then no, it's B sub n is going to be related to A sub n. You'll see how it works. All right, so we got those two series made up of positive terms. So number one, part one, if the series of the B sub n's is convergent, and so we've got the B sub n series convergent, and the A sub n terms are less than or equal to the B sub n terms in general. So we compare term by term, if you will, sort of. But A sub n, you'll see how it works. A sub n is less than or equal to B sub n. So here's the deal. Think about it now. I've got B sub n is convergent. The A sub n's are less than the B sub n's. So doesn't that make the series of the A sub n's smaller? If this one's convergent and then the A sub n's are all smaller, A sub n's got to be convergent, right? Then the series of the A sub n is convergent also. Okay? So you got two things there. You got B sub n is convergent, and then the A sub n's, you got to think about that. Make sure that's true. The A sub n's are less than the B sub n's, or equal to. Well, if both of those things are true, you got A sub n's convergent also. Because that's really, we're starting with the A sub n series. We make the B sub n off the A sub n. So that the goal is to find out something about A sub n. Okay? Well, then number two, what if B sub n is divergent? Well, if the series of the B sub n's is divergent, and A sub n is greater than or equal to the B sub n's, well, that's going the other way, isn't it? Because the B sub n's are divergent, right? If that's true. The A sub n's are bigger than the B sub n's, or equal to. A sub n's are greater than or equal to the B sub n. So I've got this series is divergent, growing infinitely large. Then the A sub n's are bigger than the B sub n's, right? A sub n's got to be divergent too, doesn't it? Because it's bigger. Then the series of the A sub n's is divergent also. Okay? Now, you can't mix and match here. All right, let's say we've got B sub n's convergent, but the A sub n's are greater than the B sub n's. Is that going to tell me anything? No. B sub n's convergent and then A sub n's bigger than the B sub n. That's still, you could have A sub n still convergent, but you also could have A sub n being infinitely large. That would be bigger. So you see what I'm saying? You can't mix and match here. It's got to be convergent in this, that means convergent. Divergent in this, that means divergent. That's only 2 times that this test tells you anything, okay? Otherwise, yeah, you just have to use some other test. If both of these aren't, either part 1 or part 2, both things aren't satisfied, you just have to use a different test. And we'll do one, I'll show you one where that happens. But okay, well, let's look at a couple of examples where this comparison test does work. Let's see how it works. Okay, so let's use the comparison test on this series, 5 over 3n squared plus 2. Okay, so that's going to be the A sub n series. This is A sub n series. In other words, that's the A sub n. And so B sub n is our comparison series. It is definitely related to the A sub n series. What I usually do is make the B sub n cut down the A sub n series by just taking the leading terms, make a series of the leading terms. So in this case, our B sub n is going to be the leading terms, the series made up of the leading terms. So the top is just 5, so you can't really cut it down. But the bottom is 3n squared plus 2, so let's just make the denominator of our B sub n series 3 over n squared. And that's going to be a nice one to compare it to. Okay? Yeah, so that series we know something about. That is, like we mentioned earlier, that's a P series. P equals 2. And how do P series work? Which ones are convergent? Which ones are divergent?
Greater than 1.
P series P greater than 1 is convergent. This is P is 2. That's greater than 1. So this is convergent. Okay, so back on the comparison test then. For the comparison test to work, you got B sub n convergent, and so you need to know also, so now the question is, A sub n less than or equal to, term by term, B sub n. Well, in this case, we've got 5 over, A sub n is 5 over 3n squared plus 2. Less than or equal to B sub n 5 over 3n squared. And a lot of times you can, I do keep dropping that. I do like for you to give me some explanation. Don't just say, hey, yeah, it is. It is. Some explanation here. And, comparison like this is sometimes it's pretty easy. Here I've got, it's exactly the same, except this one, denominator is plus 2, right? So what I could say here is these are the same, except this denominator is larger, right? Well, if the denominator here is larger, each and every n, denominator larger means smaller overall number, doesn't it? So this expression is smaller since the denominator is always going to be bigger. Something like that. Okay, so that's true. All right, so we've got what we need, don't we? We've got B sub n is convergent. We've got A sub n is less than or equal to B sub n. And so what's the conclusion? Well, it's got to be, A sub n's got to be the same as, got to be convergent like B sub n. So our series of the A sub n converges by the conversion test. And it's probably a good habit to get into, put the test that we are using here. I stated it in the problem, but okay. So that one works out. So look at it up. Any question on that? All right. Does series 1 over 3 to the n plus 4 converge? Yeah, the problem on this one is it sort of looks like maybe one we've encountered in the past, but the plus 4 here, the plus 4 is what kind of throws a little bit of a wrinkle into it. If it was just 1 over 3 to the n, hey, I know what that is, I can figure that out, but it's 3 to the n plus 4. And so that's what kicks in a different test, and that is the comparison test here. So I'm going to compare that, so that's going to be my A sub n series there. And so my B sub n, well, again, just make that series with the leading terms, 1 over 3 to the n. Make that series my B sub n series, which, yeah, that is, what is that? Again, the exponential, that, if you got the n in the exponent, exponential, geometric. We're looking at geometry. And probably put it into more of the geometric format. 1 over 3 to the n is the same as 1/3 to the n. So yeah, that's geometric with r equals 1/3. And how does the geometric series work? If r is between -1 and +1, it's convergent. So this one converges, right? Okay. So again, we've got B sub n's convergent. So again, I need to look at, is A sub n less than or equal to B sub n? Well, in this case, we've got 1 over 3 to the n plus 4 less than or equal to 1 over 3 to the n. Again, true, right? The denominator of 1 over 3 to the n plus 4 is always larger. For the A sub n. And so, yeah, so A sub n is less than. True. Okay, something like that. So conclusion then, our series 1 over 3 to the n plus 4 converges by comparison test. Okay? Any problems there? Pretty much like we just had, right? All right, here's another. This series is 4 over 2n minus 3. So, yeah, this comparison test, and the next one too, but we're just able to get bigger and better, I guess you might say, things in the denominator and the numerator. We'll kick it up a little more with our next test, even in the numerator. But one thing to point out on this one, though, do you notice here, for this comparison test, can I start at 1, technically speaking? Why couldn't I start this n equals 1? What would be the first term if I did n equals 1? 4 over negative 1, which makes it a negative term. Comparison test, you only want positive terms, so that's why sometimes on these you may see a small adjustment on n. Couldn't use n equals 1 or n equals 0. I mean, if it's a finite number, like I said, you can kind of pull those out and do a positive terms. But anyway, this is our little series here, and so that's our a sub n series. What's the b sub n? You think? 4 over 2n, which brings up the first case here where we've had this. That can be simplified. Now, for comparison purposes, later on we may want to go back to this, but that can be simplified. That's just 2 over n, isn't it? Which may be easier for you to tell then. What have I got there? Well, I guess there's 2 possibilities. You could say it's P series, or you could say it's the harmonic series, couldn't you? And either one, you got it's divergent. This is the harmonic series. Remember, the harmonic series is just where you have n to the first power in the denominator, and that's always divergent. Or it's P series, P equals 1, also divergent. Either way, okay. So this is part 2 of the comparison test. Part 2 of the comparison test says if you got b sub n divergent, and then the other part, what do we need for a sub n compared to b sub n? We need a sub n to be greater than or equal to b sub n, right? So is that true? Well, if it's nice, you got it, right? So the a sub n is 4 over 2n minus 3. And again, comparison's sake, I probably, instead of going back, let's go back to this one. Because then they're exactly the same, except you got minus 3 in this denominator and you don't here. Well, is that true? Yeah, kind of the reverse of what we had previously, isn't it? Here, I've got, the only thing different is I've got a minus 3 in the denominator. So the denominator is going to be, if I subtract 3, the denominator is going to be bigger. Smaller. The denominator is going to be smaller because I'm subtracting 3 in the denominator. So the denominator of 4 over 2n minus 3 is smaller. So that's true. So 4 over 2n minus 3 is greater than 4 over 2n. Because the denominator is smaller. That makes this bigger. 4 divided by that. That's true. Okay. Because of that fact. So I've got it, don't I? Because b sub n is divergent, the a sub n's are greater, that's got to be divergent. If that's divergent, then that's got to be divergent. By the comparison test. Okay, any thoughts or concerns on that? Okay. Now look at this one. 1 over 2 to the n minus 1. So that's our a sub n series. The b sub n would be 1 over 2 to the n, which is 1/2 to the n. That's geometric. R equals 1/2. Convergent, right? So we got b sub n convergent. So for a comparison test to work, I need what? Is a sub n less than or equal to b sub n? Since b sub n is convergent, I need that to be true. And this is one that shows you can't just assume. You know what assuming does usually. You can't just assume that it's going to work. Yeah, because a sub n is 1 over 2 to the n minus 1, less than or equal to 1 over 2 to the n. That's not true, is it? Why? Well, here I've got, that's minus 1, so that denominator is going to be smaller, right? Smaller denominator. What does that make it overall then?
Larger.
Be larger, yeah. 1 over 2 to the n minus 1 is greater than 1 over 2 to the n. Because smaller denominator means overall the expression is going to be bigger. So what do we do? Well, we just say, I can't use comparison test right now. In just a moment we will do this one with another test, but yeah, so this means you can't use your comparison test. Which means use another test. Which we haven't discussed the one to use here yet, so we'll do that in just a second. But yeah, so that just because b sub n is convergent doesn't mean you can automatically use a comparison test and say a sub n is convergent. You can't do that. It may still be convergent, but not by a comparison test.